All right, so in this video, we're going to go through sample question number 37 from the Society of Actuaries ExamP list of sample questions. It states, the lifetime of a printer costing 200 is exponentially distributed with mean 2. The manufacturer agrees to pay a full refund if to the buyer if the printer fails during the first year of the purchase, 1/2 the refund if it fails during the second year, and no refund for failure after the second year. We're asked to calculate the expected total amount of refunds from the sale of 100 different printers. Okay, so quite a bit here, but let's break it up. First thing I want to note is lifetime of a printer costing 200 that's exponentially distributed. So the lifetime of a printer, you should be familiar with an exponential distribution. It has a mean of 2. Right? Depending on where you're kind of learning this from, some people also, instead of using, I use theta, some people also use 1 over lambda as the mean. Just be aware that 1 over lambda is equal to theta, right? And then similarly, 1 over theta is equal to lambda. Let's look at the different ways the manufacturer can give a refund, right? So let's say that Y is the refund amount. So you can either get a full refund of 200, a partial refund, a half refund of 100, or no refund. And you only get a full refund if it breaks within 1 year. So let's figure out the probability of it lasting 1 year or less. So let's say X is the lifetime of the printer. The probability that X is less than or equal to 1 year is equal to, now the CDF of an exponential distribution should be something you memorize, right? Some places might say, hey, you can take the PDF and integrate it. Unnecessary. It's a very short, sweet, simple, easy formula to remember. 1 minus e to the negative x. In this case, x is 1 over lambda, which is the mean, right? I'll write the equation to the side. So probability, the CDF, I guess denoted like this, capital F sub x is equal to 1 minus e to the negative x over theta, where theta is the expected value. Okay, so calculating this, the probability that it lasts less than a year, let's see, that's 1 minus e raised to the negative 1 over 2. And that is approximately 0.393469. Right, so there is about a 0.393 chance that you get a full refund. Now, what about the probability of getting a partial refund? So that would be the probability of the following, of it breaking within 1 to 2 years, which should be the same as the probability of breaking in less than 2 years minus the probability of breaking in less than 1 year. So let's calculate. The probability of breaking in less than 2 years should be 1 minus e to the negative 2 over 2 minus the thing we got here, probability that x is less than 1. Okay, so calculating that, 1 minus e to the negative 1 is 0.632, so subtracting from our previous answer, we get that the probability of breaking in between 1 and 2 years is 0.238651219. And adding that to our previous example, right? Because we want the probability of a 0 refund, right? So after 2 years. Should be pretty straightforward. We add these two values together and then subtract with 1. And we get the probability that x is greater than 2 is equal to 0.367879441. And these are just what the calculator is giving me. I would round, obviously. Okay, so now that we have this, let's look at what the question asks us. Calculate the expected total amount of refunds from the sale of 100 printers. Okay, so we can assume the printers are the probability of one breaking is independent of the probability of another one breaking. So we're essentially asked to calculate the refund amount, y, from 100 printers. The expected refund amount, so the expected value of the refund of 100 printers, which should be equal to just 100 times the expected value of y. Now, what is the expected value of y? Well, that should be just a sum. So that's going to be 100 times the probability of a refund of 0. Sorry, the refund amount of 0 times the probability of a refund amount of 0, which is 0.368 plus the refund amount of 100 times the probability of a refund amount of 100, which is right here, 0.2387. And then I ran out of room, so I'll write it down here. Plus the probability of plus a full refund amount of 200 times the probability of a refund amount of 200, which was 0.3935. Okay, computing that gets me the following. 100 multiplied by 102.56. Therefore, my expected refund for 100 printers is 10,256. Lines up with answer choice D. Okay, so main takeaways from this problem. Know the exponential distribution. That's going to come up a fair amount, right? Of the continuous probability distributions that you're expected to know, continuous, uniform, exponential, gamma, normal. Gamma, I think, is the one to come up the least amount. It was a while back, but on my exam, I remember there being like one gamma distribution. Expect there to be something that talks about like, hey, you have a loss that's either uniformly distributed or exponentially distributed. That is not uncommon, right? And then obviously normal distribution is going to be the one you want to know more than anything else, right? Hopefully, if you were confused on this question, I helped you out a little bit. If you want, hit the like button, subscribe, because that definitely helps me out. If you have any questions, leave it down in the comments. I'll answer it to the best of my abilities. If you want to check out some other worked out problems, I have a playlist on that stuff. Go check that out. But other than that, good luck, guys.